everyone. Now, let us see. Who would like to read first? Okay. Jessica?
Today's lesson. Today we will design and complete a virtual experiment. We will generate a question, write a hypothesis, and make a prediction. We'll test our prediction using a how to read this?
PHET simulation.
PHET simulation, and revise our hypothesis as needed to write a conclusion.
Okay, so they just use too many big words. We'll just go forward because it'll be confusing if we try to talk about this yet. No. Okay, so let's make an observation first off. Okay, so next slide, we will watch a video of an archer fish. An archer fish shoots down insects with powerful water arrows from beneath the surface of the water. As you watch, consider how the archer fish hits the target with such accuracy. So everyone, what is an archer? Archer. Does anyone know? Does anyone know the sport archery? Archery.
No.
Yeah, I know archery.
Okay, tell me, what is archery?
So archery, when that you use the skill from your bow and then you shoot at your victim to shoot on.
Okay, so everyone, archery is using a bow and arrow. Using bow and arrow, you shoot at the target, okay? So now an archer is a person who shoots with a bow and arrow. So the archer fish, it shoots water at insects. It just shoots it out the water very, very fast. And it hits other insects and knocks them into the water. Okay. So this is in South America, I believe, in the Amazon. Do you guys want to watch the video?
Okay. Yes.
Okay, let's watch the video.
Animal.
Wait a moment. Let's just let it load a little bit.
Utilize their bodies.
There it is.
The archer fish uses its mouth as a bow and a stream of water as an arrow to shoot prey lurking above the surface.
Well, I think you should mute.
Not only must it hit a moving target, but it also solves a complex problem of physics in the process. As it sets its aim, the fish calculates and corrects for the refractive bending of light through the water. Its gill covers shut, thrusting water along the groove, releasing a stream of aqua arrows.
Okay, everyone. So can you see why it's called the archer fish? Now you can see it hits with such accuracy. It hits the insects. And it is because it practices so much shooting at them. But what is happening? Okay. Now everyone, here is a question for us. Okay. And we will answer together. The question, Zahui, can you read the question at the top of the page?
Why am I talking? I'm at an insect from beneath the surface of the water be challenging.
Okay, so everyone, so why might it be difficult to aim at an insect from under the water? Because what? Who knows the answer?
I think because it's hard. It is hard.
Okay, you think because it's hard? But what about, okay, so when you look at the water and you want to throw something, say you see a fish, the fish is zoomed in the water when you see it. Okay, so like the light refracts off the water and it makes it look more forward or behind. It's not exactly where you see it. Okay, so does anyone else think anything?
Maybe from underwater, water shook
and make the fish can see the insect very well.
Okay, so it might not be able to see it very well because it's in the water. So let us see. All right, anyone else? Let's see. Miley, can you think of anything? Zabing?
I think because when we dive in the water, it's too hard to see carefully in and beneath the surface of the water.
Okay, so this is due to refraction. All right, refraction, everyone. When you see something, then the fish will seem closer, or the bugs will seem closer or further away, okay? So we have refraction. Okay, this is when things seem in a different place. So when you look into water, when you look from outside the water into the water, generally the fish will look bigger than they actually are. So, and maybe they'll be a little bit more forward or a little bit more behind. Okay. So the also he was maybe shoots from the water, and it's not straight because it'll hit the other water, go change direction like that. Okay. So we say it is refraction. Okay. Okay. Now, everyone, what do you want to know about light as it travels between air and water? Okay. So once again, the water can refract light. When you shine the light in water, it will magnify it at first, but if there is a light that is not very, very bright, it will stop it. It will block the light.
Yes.
Okay. Does anyone else think, what do you want to know about light as it travels between air and water?
Light cannot travel into air and water.
Yeah, it's from the air here into the water. So sometimes it can see deep. You can see if it's a bright, it will shine right into the water. If it's a dim light, it will sort of reflect off the water. So it's the refraction once again. It will reflect off it.
Yes, so how to solve this problem?
Yeah. So yeah, testable questions are different from other types of questions in that the answers must be supported by evidence. Okay, you're gathered through experimentation and investigation. That's a testable question. Is evidence. Okay. Now, what are the independent variables that affect the refraction of light? The independent variables, everyone. These are the ones that are their own. So we'll say the water is an independent variable and the light source, okay, where the light is coming from. These are independent variables. The dependent variable would be maybe the angle that the light is shining at the water. Okay, who would like to read this? Miley, can you please read this?
Independent.
Material
Above. Material below. Angle of light source. Position of light source. Dependent. Angle of refraction. Resulting intensity.
How strong it is. Wavelength, how deep it is, how strong it is,
Wavelength.
and how wide it is. Okay.
Resulting
So
rate.
so everyone, all of these things, the angle of the refraction, how strong it is, resulting intensity, resulting wavelength is how long it goes for, and then resulting ray, long, strong, big, dim. These are all dependent on the independent variables, okay? So the position of the light, and then the position of the water, the angle that it hits the water. These are all dependent. Those are all independent. Okay. Do you guys understand?